It says determine the components of F that act along rod AC and perpendicular to it. Point B is located at the midpoint of the rod. I'm going to start off with some givens and the find, and then we're going to talk together and see if we can come up with a strategy of the steps that we might want to take to solve this problem. It says determine the components of F that act along rod AC and perpendicular to it. So we have to figure out exactly what we want to call those two things. Typically we will use F AC, F perpendicular. How are we going to find F as a vector? Unit vector BD. I need position vectors. Very good. That's how I'm going to find that unit vector, right? The unit vector BD is the position vector BD over its magnitude. And then finally we can say that F as a vector is going to be equal to the magnitude of F times that unit vector BD. All right, we're getting somewhere here. That would give us F. But we may need the dot product. If we're trying to find FAC, can we write the equation of what FAC is equal to? Well, if we want the vector FAC, we know that that's simply going to be equal to the magnitude of FAC times a unit vector in the AC direction. That's a pretty simple one. That's exactly what I set up here, just using different variables. How could we find UAC? Very nice. Vector RAC over magnitude RAC. Okay, so how can we find the magnitude of FAC? This is from the last slide. I have to do something with F. I have to dot it with something, with a unit vector in the AC direction. Okay, so we could actually write this, we could expand this and say that FAC as a vector is going to be equal to F dotted with unit vector AC, which is actually going to end up being a scalar, because the dot product gives us a scalar, and then remultiply it by UAC to get that direction back into it. We need F, right? We have the magnitude of F, but we need F as a vector. So I think that would be our first step, is to find that. So what do we need to find F as a vector? The vector BD. So there's a couple ways we can do this. Now, it's said that the midpoint of AC is B. It's completely up to you how you're going to visualize that. You could say that I could have a vector. Now, these are position vectors. Position vector going from B to D. That's our goal. That's what we want, is to find that, right? Well, if we knew this position vector from A to B, and we knew this position vector from A to D, you can see that there's an equation, a tip-to-tail relationship happening there. Can anybody tell me what that equation would be? The three vectors are RAB, RBD, and RAD. RAB plus RBD equals RAD. How did I get that? Well, I start at the tail. There's only one place where there's two tails that join. And then I go to the tip. So from tail to tip is RAB. And then which one is that attached to the tip of? RBD. If I made a mistake and I went the other way, I would know right away there was a mistake. Because when I get to the tip, there's another tip. It's not tip to tip. It's tip to tail, right? So this triangle tip-to-tail relationship is shown right there. What do we want out of this? Well, we want RBD, which we can clearly solve for. That's going to be equal to RAD minus RAB. So that's one way to get it. The other way is to logically step ourselves standing at B and walking to D. Now, we don't have any components of B, but maybe we can come up with those. Okay, so if we're going from A to C, how far do we go in the Y direction? Okay, so this is 4 from here to here. How far is it from the Z-axis to B? in the y direction? 2. It's half of it, right? So we know that the y-coordinate is going to be 2. What's the x-coordinate? 1.5. And how did you get that? 3 divided by 2. So if you look at it, if we the x-coordinate of A is 0. The x-coordinate of C is negative 3. So if we take that x-coordinate of C, we know that it's negative 1.5. We're dividing it by 2 because we know B is the midpoint. So negative 1.5, 2, and then what is the z component of B? Positive 2. Positive 2. If you look at the origin, which is right here, to get all the way to A, we'd have to go 4, but we're only going halfway. So 2. So we now have the coordinates of point B. If we're at point B and we need to go to point D, how far do we go? So RBD equals. So if we start at negative 1.5, and we end up right here at D, well, that's 4 meters from the y-axis. So we started negative 1.5 behind the y-axis. We walk 1.5, and then we walk another 4. That's going to be 5.5 I. Okay, how about in the j direction? 6. So if I start at 2 and I go to 6, how far did I go? Positive or negative? Very good. So you can see there's 2 ways to solve this problem. There is completely manual plug and chug, which it would be this method. This method would be you have all the coordinates, find your BD and your AB, and then solve for BD using vector algebra. The second method is to visualize, stare at it, and see if you can figure it out. Your choice. I actually prefer the picture, looking at the picture and finding this stuff out. Okay, how about the k direction? Negative 2. Good. We're starting at 2 and we're going to 0. So negative 2. Okay, so we have RBD. That's awesome. What are we using that for? To find our unit vector UBD. Okay, so I think I'm going to finish this on this page. So now we need UBD. That's going to be equal to RBD over RBD, which would be 5.5I plus 4J minus 2K over the square root of 5.5 squared plus 4 squared plus negative 2 squared. Meters on top, meters on bottom. We're going to end up with a unitless unit vector. Okay, those are the numbers I ended up getting. So we have a unit vector BD. Why did we get that, and where is it leading us to? Boom. Times it by f to get our f as a vector. F as a vector is going to be equal to the magnitude of f times UBD, which would be 600 newtons times UBD. You have to keep going. I'm cutting you loose. Time for you to talk to your neighbors and figure out what the next step is. I'm going to come around and answer questions for you. So this is what I have so far. I found my RAC. I talked to each group. You guys were all heading the right path. RAC I got is negative 3 plus 4, negative 4. I found the magnitude, and then I found my unit vector AC. That's how far I've gotten. What do I do next? Exactly, because what we're actually looking for is the projection. The projection, you can picture a projector. We're going to project F onto AC. The projector is parallel to AC. It's shining a light on F, and what we're going to get is the shadow of F on AC, which would look something like that. It's kind of small, so it's hard to see, but that would be FAC. That's what we're trying to find. So FAC as a magnitude, not as a vector, is going to be equal to F dotted with UAC. Okay, so I went ahead and did the dot product. Now, hopefully you guys remember how to do the dot product. It's a pretty simple calculation. The biggest thing is you got to train your mind that the dot product is a scalar. And since the dot product is a scalar, we don't have i's, j's, and k's. The i's, j's, and k's go away. So you can see that I got 81 newtons. I got a number. Should I just box that and call it good? We're done? Yes, you're right, it should. So I screwed up. Because there's two negatives there. I missed my negative up here. So, see, about right now is when I'm really happy that I wrote this out and that I wasn't lazy about it, because it's very easy to fix my problem now. Is that what you got? Okay, good. I must have done something right this time. Okay, so we now have how many newtons FAC is. Is that the answer we want? It's part A. Good. That's part A. That's FAC. There's one more thing we need, and that's F perpendicular. How do we get that? Well, this is where your drawing comes in. Earlier I was asked by somebody, do we need to draw this? Yes, always you need to sketch it. So what I'm going to do is I'm actually going to blow this drawing up, and I'm going to first draw my AC in black. I'm going to draw my F vector like this. That's our F. Okay, then I'm going to draw my FAC. Okay, where's F perpendicular? What does it look like? It connects FAC to F. That's one way to look at it. You can also look at it as coming from F, the two components of F, right? One of them parallel to AC and one perpendicular to AC. But then what do we do for vector addition? Exactly what you said. We're going to slide that F perpendicular. We're going to slide that to the end of FAC to make a triangle. It doesn't look very good, so I'm going to fix it. Okay, so we have our F parallel and our F perpendicular, and we just need to come up with an equation that relates those three. FAC is a vector plus F perpendicular equals F. That's our tip-to-tail relationship. Do we have F? Yes. Do we have FAC? Close. We have the magnitude. Do we have the direction of it? Can we put those two together to get FAC? All right, so that's where this other unit vector comes in. So now FAC as a vector is equal to FAC as a scalar times UAC, which means FAC is that magnitude we just found, 130.38 newtons, multiplied by UAC, which is negative 3 over square root of 41i, plus 4 over square root of 41j, minus 4 over square root of 41k. Calculators come out, and we get FAC. That's one method. Can anybody find an easier method? I'm going to redraw this triangle.
Well, isn't that perpendicular, so we can just do a squared plus b squared c squared?
Very nice. This is the Pythagorean theorem, right? So we have FAC, we have F parallel here, and we have F here. If we know that this one is 130.38 newtons, we know that this one is 600 newtons. We can say, this makes it a little bit easier, we can say that 130.38 newtons squared plus F perpendicular squared equals 600 newtons squared. Solve for F perpendicular.